Thank you everyone for joining us for this webinar on From Idea to Output, the development process of a moving light with Brad Schiller. My name is Mallory Misnarsik and I'm the project manager here at Harman. A few things before we get started. Everyone on the call is muted to keep down noise levels during this webinar. However, there is a Q&A function where you can submit questions to the presenter and he'll try to answer as many questions as possible at the end. This webinar will also be recorded and a link will be made available a few days after this presentation. We do have a number of other webinars taking place over the next few months for audio, lighting, video, and control. We encourage you to take a look at our different webinars and our Learning Sessions workshop series on pro.harman.com, as well as visiting Harman Professional Training to see our many on-demand and certification courses that are available to you for free. And now I'd like to introduce you to Brad Schiller, the presenter for today's webinar. Brad has been involved in automated lighting for over 30 years and is currently a business development manager at Martin Professional. He is the author of the Automated Lighting Programmer's Handbook and a regular columnist for PLSN. A self-described lighting geek, Brad enjoys sharing his knowledge with others. And now I'll pass it over to you, Brad.
Thank you, Mallory, and thank all of you for joining me today. This is really an exciting topic. I've been wanting to talk about this for quite a long time, so I'm very happy to have the chance to share this with all of you. And as the title says, we're going to talk about the development process of a moving light. So I'm going to go through everything from idea all the way through to finally getting a light on a stage. And before that, I'm going to talk a little bit, just some background of our industry and history and things. So how about I get started? Here we go. So first of all, when I started off and I was much younger, a long time ago, like most people, I wanted to be a lighting designer. And I've been able to do that. I've designed many different shows in my career and all, but I started off working as a lighting technician and a lighting designer, and I had great aspirations of designing lights. What I didn't know is that I would have opportunities to actually help design the lights. I thought I would be a lighting designer in that sense, and it's been a really terrific thing to be involved with the design of actual products. But for me personally, as I said, I've worked as a technician, a programmer, and a designer, and as a programmer, when I started off lighting programming, that was a very new concept to the industry. Moving lights were rather new at the time. And actually all programmers, or most programmers, worked for manufacturers. So that was my inroads into working for a manufacturer, was that I wanted to be a lighting programmer and thus had to go work for a manufacturer. Since then, over the many years, I've worked in many different positions in 3 different manufacturers as well. So throughout the industry, I've worked in many different positions, had a lot of insight into how a manufacturer works and how they sell and how products are created. But most importantly, we're going to talk about my time as being a product manager. When I was a product manager, I was very much involved in the development of things for lighting products, for consoles, for media servers. I've been very fortunate to be involved in a lot of different aspects of development in the industry and to work with some really amazing teams to help design and develop these products. And it's really a fun and exciting thing to do. And we'll talk a little bit more about that later on. But one of the things I really like, again, about it is I've been able to be a part of designing lights to go and see them on a show and see what somebody else can creatively do with these products that you get involved with is something I never imagined early in my career that I'd be involved with. I thought, being a lighting designer was wonderful and satisfying enough to work on a show. But it's extremely satisfying to also work on products and then see other people take those and expand them into something even further. As far as this presentation, I'm going to speak generally. I'm not going to be giving away all the secrets of exactly how we do things at Martin, because yes, I am employed by Martin, and we do follow a process similar to what I'm going to describe, but I'm not just describing the way Martin designs and develops automated lights. In this presentation, I'm going to give you a lot of background and information that comes from my mind, from my experience, from things I've been involved with, from colleagues I've talked with that have similar work in different manufacturers. I'm going to give you a basic overview of where we are now and how an automated light is developed now. I'm going to talk a little bit about the history that's coming up next, but also when I start talking about how a moving light is developed, please understand this is a general discussion. Some companies will do it very differently, some will do it very much the same, and this is where we are today in this point of 30 years into the development of moving lights. The other thing is this also comes from background. As I said, I've worked with 3 different manufacturers. that actually then became part of a bigger corporation. And also I've worked with some foreign manufacturers, some firms in China and other locations. So I've got a pretty good range of experience to put this all together into a general presentation to explain how moving lights come to be. But before I go into that, let's look at the history. Let's understand a little bit about how the industry has developed and changed over the years, because it's matured for sure. Uh, Everybody kind of knows back in the 1980s, that was the big moment for entertainment moving lights. That's when Verilight came to be in Bullring in 1981. And throughout the 1980s, it was kind of the Wild West. You had a lot of companies forming. You had Martin was formed back then, Verilight, a bunch of other companies all formed and came together designing different types of lights. Now there were patents, of course, so a lot of companies like Martin were making mirrored lights, lights that used a mirror to project the light and show it, as opposed to the yokes, what we see around everywhere today. But the reason I call the 80s the Wild West is because it really was almost kind of like when you think of how Microsoft or Google started in a garage with them putting together the pieces. Well, the 1980s really was kind of the Wild West of our industry. It was a lot of really smart people kind of getting together and saying, wouldn't it be cool if we did this and it moved and it changed colors, and they would kind of put it together. There wasn't really solid companies and solid processes. Sure, some people were heading that way, but it was really, like I call it, the Wild West in the 80s. Things were getting developed and figured out. As we moved into the 1990s, we started to see a lot more innovation and a lot more companies kind of solidify into what they were. I call this the revolutionary period. This is when people really started to realize, hey, this is an industry. The entertainment industry was growing and actually accepting automated lights. They weren't just for concerts or for discos or nightclubs. They were actually moving into Broadway, and they were moving into television and becoming a very legitimate part of a real industry. And it really was starting to really take off in the 90s. And we saw lots of different things happening. We also started to see lawsuits. There were some lawsuits, very important lawsuits in our industry that happened that had an effect on the development of lights. And towards the end of the 90s, we saw a point when those lawsuits happened, but also patent barriers were broken. People started using, other companies were making moving yokes. And there were, again, lots of different companies out there. There were the major ones that you know of today, but there were also lots of smaller companies all around the world developing moving lights. And the process was pretty good at that point. As we moved into the 2000s, we started to see a lot of venture capitalists and corporations. People looked at our industry and they said, oh, you know what? There's some money to be made there. This would be good. Let's invest in it. Plus, it's really cool and fun. We get to have products on shows. So in the 2000s, we really started to see this investment into the industry, and it allowed for more professionality. The companies that were producing lights became more professional on their assembly lines and how their processes and how they developed the lights. There were a lot of things that changed in that realm, but also competition got really, really strong between the major players in the industry, and that really drove a lot of innovation. People took a lot of risk. They tried new products. We saw digital lights emerge. We saw media servers come out. We saw consoles change. Lots of things happened in the 2000s, and it was really an exciting time for our industry. As we move forward into the 2010s, what we saw there was kind of a commoditization of the products and of the industry and of the design of moving lights. At this point, the most recent time in the 2010s, if you will, what we saw then was that LEDs became the major light source, but we also saw lots of different companies coming in from overseas. We saw a lot of different manufacturers come from China, and we saw too many products too fast. And what happened was everything became good enough. So you may be very much aware that a lot of lighting designers, for example, would specify, I need a moving light that is this bright with this many gobos and framing shutters. And they didn't really care if it was from this brand or that brand or another brand. As long as it met the specifications, they knew it would be good enough. And the prices dropped, competition kind of dropped. Everybody did the same thing. We're trying to just one up each other. And it's really been an interesting time for our industry because it kind of flattened out and we lost a lot of innovation. I'm not saying there wasn't innovation. There has been a lot of innovation all throughout the range of automated lighting, but The 2010s, we really saw that commoditization of the industry and the flattening out of pricing and even to an extent, some of the innovation. As we move forward going into the 2020s, I think we're going to see a regrouping of the industry. We're going to see less products and hopefully more creativity and more innovation as well, and probably fewer competitors, where everybody's been chasing that bottom line, let's get the lowest price and good enough products. I think we're going to see a change to that as we move forward into the 2020s. I think we're going to start to see, again, more innovative products and new ideas coming to play and really changing the industry once again. Maybe even a new peek back to the Wild West as people really start to play and develop new lights. By the way, if you want to get a better idea of actually what products were developed in these different time frames, coming up on August 25th at 11 a.m., there's another webinar happening here through Martin that myself and Craig Rutherford will be hosting. It's called The History and Evolution of Automated Lighting. And we're going to go through this entire history and talk about key products that really changed our industry and what those products were and what those innovations were inside those products that really drove our industry. So that's going to be real exciting. If you're watching this seminar recorded, then that one's probably also recorded, and you can find that on the Martin website. So again, that's August 25th at 11 a.m. All right, so moving on, we're going to talk about the manufacturers themselves. So when you think of a manufacturer, you think of a company that has a big factory, they build the lights and they sell the lights. And that's traditionally what a manufacturer is. Our industry actually has several different types of manufacturers. It's not that straightforward. For example, there are manufacturers that they do build their own products and sell their products. You probably know of some companies like Robe and Clay Paky. They are still doing that. Martin, we did that at one time, but you'll see we fit into a different category today when I get to that moment. But these manufacturers, they own the factory, they have their own factory workers, and they build all their own products and they sell their own products through their own sales channels. Another type of manufacturer is actually a distributor. There are manufacturers in our industry that they sell their own products, but they don't actually manufacture them. They don't own the factory. They don't own the factory or have the factory workers as employees. They actually contract out to another manufacturer to build the lights for them, build it to their specifications. So they will say, I need a light that has this many gobos, color mixing. They might even give some unique ideas to that manufacturer and say, you know, I want to patent this little thing in the corner that inserts a strange object into the light's path. I don't know what they come up with. They might come up with unique things and work with another manufacturer to make that light for them. Then they sell them a whole lot of that light that they turn around, this distributor manufacturer, they turn around and sell that as their own brand to everyone out there in the lighting industry. And there's companies like Elation, Chauvet, and Blizzard who do that. They go out and they specify and purchase their products from other manufacturers, and they sell them and they maintain them, and they do the entire cycle of support and everything because it is their product. Of course, going along with that, there are OEM manufacturers. There are manufacturers that they just own the factory, and in their factory they build the lights and they sell the lights to other people. They sell them to the distributor. They might not have their own brand. They might just be building these lights for another company to sell because they don't want to have that whole side of the business where they are trying to sell the lights. They just want to concentrate on being a factory. Now, there are some like that out there in China. There's Golden Sea, there's Acme, and in fact, Robe actually started off that way as well. They start off building lights for other companies, and then over time they said, you know what, we could make our own brand, and they shifted over after they learned building for someone else. They shifted over to making their own brand and selling their own brand. It's very interesting, different types of manufacturers. So then that comes to what I call a hybrid manufacturer. And this is where Martin fits in today, and some other manufacturers in our industry as well, where we still have a factory, we still have engineers and people on our team that develop and design products, and we make our own products and we sell our products. But in addition, because of that commoditization I was talking about earlier, we have to make more products faster to keep up with the market and to compete. So what do? We go to an OEM manufacturer and we specify products that we want. We tell them exactly what we want to buy. We might even share some intellectual property with them and say, you know what, we have a patent on using color mixing in this way. We're going to share it with you, with the OEM manufacturer, but you can't use it for anyone else. It's only for our products. We'll do that, and then they will manufacture products for us so that we can then take those and resell them through our channels with our own brand. So a hybrid manufacturer has their own factory, but they also act as a distributor type manufacturer where they're also selling products that come from a different factory. And again, that's the way Martin operates today. Verilight, High-End, many different companies are doing that, where they have their own factory, but in order to compete, they also are bringing in products from other factories. And again, they're not just purchasing them off the shelf, they're actually going in and specifying what they want from those factories. And then there's the hybrid OEM factory. And a hybrid OEM factory, this is where they actually build for other people, but they also realize that they can compete in the market and they might build their own product with their own brand. Going back to a company in China called Golden Sea, they manufacture for quite a lot of people, for different distributors and hybrid manufacturers, but they also manufacture for themselves and they sell it under their own brand. And their own brand in China is called Terribly. In other parts of the world, they also sell under the brand name of Eriton. So now you have a factory that can produce many different brands of products. They produce for other companies and they produce for themselves. And that helps them immensely because they can buy in quantity all the elements and components of lights, and then they can sell at a lower cost. Plus, they're making revenue on the lights that they're selling to other companies that are distributing for them. In addition, what happens is they have a higher control of their competitors. So if they have their own brand, they can make sure that their own brand, say they have a lighting engine that can produce 60,000 lumens of output, they can tone that down for the people they're selling to, that they want to sell them as a distributor. They sell to that other brand a 50,000 lumen output, and they keep that extra 10,000 lumens for themselves, so their product that they're competing with is a better product in terms of output. That's another type of manufacturer. And then finally, the last type of manufacturer we see in our industry is actually a production company. PRG, they have their own factory and they actually build their own products. They build the Bad Boy and Best Boy and other fixtures. They have their own staff. They build the products. They maintain them. They don't actually sell them. They tried here and there, but they have them in their own inventory for use and for rental. They also make use of outside OEM manufacturers, and they specify and purchase products from other manufacturers, as do other production companies such as Bandit and Upstaging and others out there. They find places in the market where maybe it works in their benefit if they go to a manufacturer directly and they make their own branded product. Maybe it's because they can't get that from one of the key manufacturers in the industry, or maybe it's just they want to do that to have their own unique product. There's many different reasons. But as you can see throughout our industry, there's a whole wealth of different types of manufacturers. So not every manufacturer is the exact same. However, the process of actually getting from an idea to the output on stage is relatively the same. Again, it varies from company to company and manufacturer style to manufacturer style, but overall, it's pretty much the same. And that's what we're going to dive into next. So, when you want to design a new moving light, you've got to start, like anything, with an idea. Where does that idea come from? Well, there's ideas floating around out there all over the place. Many different people and concepts and things can come together, but how do you bring all that together into what's going to ultimately become a product? And that starts with typically a position that is a product manager. Now, there have been times in the Wild West period of our industry where maybe there was a very strong person in the company that wasn't designated as a product manager, maybe just the owner of the company or someone that really just says, we're going to make this, and has an idea of what they want to make. That could be. But in today's more organized fashion, it's typically someone who's a product manager or product marketing manager. And their goal is to actually see a product all the way through development. They oversee and watch that. But early on, they have to come up with what is the idea. Now, they could sit around and just think out of their head, what should I make tomorrow? What kind of light? But it doesn't work that way. You've got to look at all these different elements. Product manager has to get ideas from lots of different places. These places come, the product manager will talk to a lot of different groups of people to get ideas of what the next type of moving light could be. They'll talk to the sales team to find out what products sell, what they think might sell, what doesn't sell, what's causing problems in the sales team's orders and all that. They'll talk to engineers to find out new ideas that engineers might have, the actual people who build and design the light, they might have an idea based on the previous time that they designed a light. And they might say, you know, when I was working on the last light, I had this thought, but we couldn't work it in. Can we work it in this time? And they might come up with a really great concept. You might also talk to vendors. The vendors are people that come to the manufacturer and sell products. So they might sell a new light engine, an LED light engine. And they might say, you know, we have this one now that produces 600,000 lumens of output. Do you want to buy that? Or sometimes they bring really cool ideas. I've seen vendors shop around and they'll come to a lighting manufacturer, maybe with a piece of glass, that when you charge it electronically, that glass will change from clear to opaque or transparent. It'll change depending on the electrical current. Can that be used in a moving light? Maybe, maybe not. They give you great ideas. You want to talk to the production companies, the actual people who are buying and renting those lights. They might have things they want to tell you that, you know what, we want to make sure we can fit the light into this size road case, or it needs to be a certain color or certain whatever it needs to be to better fit their business model. And of course, you've got to talk to the designers and the users, lighting designers, lighting programmers, anyone who's involved in creating the shows. Those are really the key people you want to talk to as well to get ideas for the next new moving light. Do people want it with certain output, certain feature? Are people still using gobos? Are they not using gobos? What's important? You want to check that out. You want to look back at your current products. Does that product need a new iteration? Do we need to move that product into a different one? Can we just change it up a little bit? What worked, what didn't work? You've of course got to do your market research. You need to understand the entire industry, the moving light industry, as well as the entertainment industry. What is going on? What are the trends? What are people seeing and using? What is it that's going to be useful going forward for a new light? And then you also talk to the support team. The support team will tell you what worked and what didn't work, and where problems lie. And with all that, you can start to gather in on an idea of what the next moving light product could be. But that's not enough. You've got to look a little further. So you expand that circle out, and you'll talk and look in many, many other places. So perhaps you might look and go talk down on the production line in the manufacturing area and ask them, how is it working? What have you been building? How can we improve the next light to make it lower cost or even stronger or whatever? Maybe they have ideas. The guy who's been QCing the lights down in the manufacturing division in the factory might have an idea for you. You might look at art and nature. You might watch the way the sun shines or the lightning hits, and that might give you a new idea for a product or a feature of a product. You can look towards other industry. The automotive industry is great. You can get good ideas of trends and things they're doing there. There's a lot of different industries and ideas you get. Productions, you can go off and look at different shows and not just look at the show and how people are using the current lights, but look at the overall production itself. What do you think, what would inspire you to make that more exciting? What can be used? Of course, you've got to study the competition. You've got to look at the competition and see what kind of lights are they making. Do we need to make one like that? Are they having a real success? Or is that just a trend? What do we need to do there? There's unexpected places that ideas can just pop into your head with the least you expect it. You could be doing lots of different things and get an idea. Once I was watching a movie and I saw the closing credits and they did this cool effect on the closing credits. And this is when I was working with a media server, and I said, you know what, that effect would be really cool as a media server thing. So I wrote up a spec, I turned it over to the engineers, and they actually created an effect that was implemented into the media server based on an idea that was triggered from watching the closing credits of a movie. So ideas can come from unexpected areas. You can, of course, do surveys. You can get ideas from doing surveys with many different people. And you can talk to the employees, other employees in your own company, maybe the management, maybe somebody else in different divisions besides just the manufacturing and sales and support. There's a lot of different people in our industry that have lots of great ideas. So the product manager has to go out and seek these ideas and formulate them and kind of mold them into something that can then begin to get developed. And this happens, again, the product manager will take these ideas and kind of mold them and write them down. And once they kind of solidify an idea, they will put that into something and they will write down some simple specs. So this is just a rough idea of what is this product? What could it be? Well, I want to build a moving light that is as big as a pencil, but has 200,000 lumens of output and 400 gobos in it. That's my idea. So you kind of write that down and you get that concept solidified a little bit. Then the product manager has to take that idea and take it around to different stakeholders within the company to see if it's even viable. Can we do this? So you'll go talk to engineering and you'll say, here's my idea. It's kind of just a rough idea. I want to make something that looks like a pencil that has all these gobos and all this output. And they might look at you and say, you're nuts. We can't build that. Or they might say, oh, yeah, we could do that. We've been looking and we just saw this new light engine that was developed last week, and we think we could use that for that. And so you kind of get some ideas and kind of confirm the concept. Then you've got to talk to sales. When you talk to sales, sales will tell you how much is going to cost. That's the first thing they're going to ask. Then they're going to tell you, I'm not sure if we could sell that or not. I don't know. Or they might say, that's it. That's a winner. We could get that. We could sell thousands and hundreds of thousands of those. So that's really where you get an idea, is this a good idea or not? Or they might give you a concept, say, instead of a pencil, make it a little bit bigger around because that's going to fit better in our world of sales. Can you make it a little bit larger? Can you make it do this or that? And so you might then add and tweak a little bit to the initial concept. You might also hold focus groups. You might gather in some lighting designers or end users of sorts and talk to them and say, here's kind of an idea we're floating around. Would you like a light that's really small, like a pencil? Kind of float that out. Or it might not even be that organized. It might just be conversations. So perhaps maybe you've met up with a product manager at a trade show, or you've met up with a product manager at a group dinner or a lighting demo, and they might ask you questions like, have you ever thought about a light that has 300 gobos? Would that be useful to you? They might not give you the full range of what they're thinking about, but they might drop little hints here and there to kind of get your feedback, and that's a way they're confirming if that's going to be a good product or not. And then finally, they also have to kind of confirm with the finances of the company, is this something we're going to actually be able to take on and build this product? Because it takes a great investment of time and money to build a new light. So you've got to see if the company's healthy enough and has the drive and the money in order to take on this project. So once you've kind of confirmed, once the product manager's confirmed that, the next step is to actually evaluate and determine a timeline. Is this a thing we can make in our business? Is this going to work? So they will evaluate it and they'll look at the development. How long is it going to take to actually build this light? Most lights take, from the engineering process, approximately 2 years. It depends, but approximately 2 years from when the engineers start on it till we get to the actual end product. But is there technology you're waiting for? It could be that there's that light engine that produces 100,000 lumens of output, but it's not going to be out until next year. And so you've got to wait 6 months, 8 months, a year before you even get the first sample from the vendor who makes those new LEDs. So there's sometimes you might have to wait on technology, or it might be that you have other products in the development cycle, so you've got to wait 3 years before you can start this. You need to look at the market. Is it, by the time we make this light, is it going to be viable? Is it going to be something people want? Will our competition already trumped us and have something better? And you've got to decide when you're going to launch this, what year, what time frame, roughly. So again, at this point, the product is just a concept. We still haven't even begun developing it yet. There's a lot that goes in before the engineering starts. At this point, the product manager generally has to build what's called a roadmap. And the roadmap is something that is typically updated about every year. About every year, the roadmap is updated, and this just gives everyone in the company an idea of, these are the products we want to make in the future and approximately the time that these products will come out. It doesn't mean that we're going to build these products. It could mean that it's going to shift and slide. In fact, they pretty much always do shift and slide further out. There's many different conditions in the market and in development of current products and everything that have a great effect on what the timeline reality is. But the roadmap gives everybody a solid idea of kind of the plan of the company. And roadmaps could be 5, 6, 8, 10 years out. It just depends on each company where they're looking at. So what does a typical roadmap look like? Well, here's an example of a roadmap. And don't get too excited about these products. I mean, they're cool, but I don't know if they're coming out on these days from anyone. But basically, each product manager will organize a roadmap and manage this roadmap. Again, it's updated about once a year. And the roadmap will just put out there and say, each year which products they plan to release at that time. Now, this one shows for 2022 through 2024. If this was a real company, hopefully you'd just be starting on the products that are coming in 2024. Hopefully you'd be in the middle of the development cycle of the products coming in 2022 and 2023, because it takes quite a while to get these products actually developed and onto the market. So again, you've got to be looking forward. And on this, you might not have a real name of the product yet. You just kind of have a concept, and you might have a code name, or you have the concept there. And then you have really just a rough idea. What is it? You don't have to have all the full specs, just something so that the engineers, the management, the sales team, people can look at this and say, oh yes, okay, our future is we're going to come out with a new light that's going to be, an LED beam with 500,000 lumens and with a super zoom that goes to -10 degrees, whatever that is. And on the timeline, not only do you show what year it is, but you kind of see that they show where in the year the product will be released. Quite often in our industry, we will focus on major trade shows. So we'll say we're going to launch products at LDI or Pro Light and Sound. Those tend to be the two times that people will launch products. Doesn't mean they're actually for sale at that time, but that's when they're announced to the public. So that's why you kind of see that timelines will show something towards the beginning of a year and end of a year, because that kind of aligns with those trade show times. So this roadmap is then used, again, updated annually, usually in some sort of road mapping meeting, and it's just kind of used as the guide so that everybody's on base of what the plan is for the company. The next step, again, is involving the product manager, and this is where you actually start getting the project planned. Now, we still haven't approved that, yes, we're going to start it yet with the engineering team. That's coming up. Oh, at this point, it has to still be fully solidified, because remember, at the moment of the roadmap, it's really just a concept. So now, what has to happen next is full specs have to be made. And typically there's two types of specifications. There's what I call the marketing specifications. These are the ones that ultimately you'll see on the web page that tell you how many gobos a light has, its zoom range, its pan and tilt range, what it weighs, just kind of basic information. And then there's the very detailed engineering specifications. And these are used by the engineers to give them the metrics they need when actually producing this light. So the engineering specifications will say things like gobo rotation needs to go from 0.0001 speed to 5,000 RPM speed, or we need it to be this range of color mixing, or as good as a previous product but better than this product. There will be very many metrics defined in there, and that tells and guides the engineers when they build the product what they need to work towards. So those specifications will be made, not always by the product manager, but sometimes by other people as well. Next, what happens is people within the company have to research the cost. What's it going to actually cost to make this light? Well, you've got to come up with the bill of materials. What are all the parts that would go into the light? You might have to take into account tooling or 3D printing of parts for figuring them out, getting them made, what that's going to cost. Tooling means you go off and maybe you have to get injection mold covers, or you have to get different parts made out of metal and different things that have to be tooled up and made, and that comes with a high cost. You have to budget for prototypes. You have to do testing. It means you have to get your internal staff. There's a time and a cost associated with testing those lights before they come out to the end user. You need to factor in certifications, things like UL listing, EU listing, FCC, and manufacturing themselves. What's it going to cost to rearrange the manufacturing line and build into the factory? What special tools do you need to make these lights? All that has to be researched, and the dollar amount has to be determined. This is before we even start the project still. Then you talk to the sales department. And the sales department, this is very important, you've got to determine how much money is the company going to make on this light. So you've got to find how much could we sell the light for. Once you know the bill of materials and the tooling and the cost, that might already tell you that you've got $8,000 invested in this moving light. Well, what can the sales department sell it for? It better be for more than $8,000 because you need to make a profit. So they have something they work towards that's called a margin. They need to make a percentage of that, so they will mark it up from what it costs to actually make it so that there's a profit worked in there. So that has to be determined, and most companies have preset margins that are required that they have to make. And if a light can't make that margin, then it's a no-go product. It's not going to happen. So you have to work with and figure out the pricing with the sales team. They also need to figure out how many lights do they think they can sell over a time span of maybe a couple of years. So are we going to sell 1,000 of these lights a year, or are we going to sell 5,000 of these lights a year? What do we think is going to happen? And then from all that, the return on investment can be calculated. So now we kind of know what it's going to cost to make. We know about how many we're going to sell and what we're going to sell them for. How much profit are we going to make? That's what's really important to a company. That's what keeps a company alive. You also need to consider the time. How long is it going to take? How long is it going to take engineering to develop this product? Is it something that has never been done before? It might take longer. Maybe there's a new color mixing method that they want to utilize that needs more testing and more time and more money, and it might take even longer to get the product out, so you need to allot 3 years. In the terms of lighting consoles, it takes many, many years to get those products out. So you've got to determine what is the timeline. Again, things like certification and when are you going to launch it? Those all become important factors for determining the viability of this product. And so the product manager and others will take all this information that's been gathered and put it together into some sort of presentation, usually a PowerPoint type thing. And what's really important in that presentation is what's it going to cost? How much are we going to make? But they have to have all the facts in there. It's best you can figure out. All that information has to be in there. And again, this is after it's been approved to be on the roadmap, but before it started to be developed. So finally, all that information goes to some sort of meeting. It could be a product development committee. It could be a high-level management meeting. But at some point, this is the moment when the company decides, are we going to make this product or not? Because they'll look back and they'll say, okay, this product costs this much money to make. It's going to cost us $2.3 million and take 2 years of our engineering time. And we think we can make $10 million on this product. Yes, let's do it. Or they might look at it and say, well, it's going to cost $4 million to make. It's going to take 3 years. And it's a risky new type of product. We maybe could make $5,000, $6,000. They might say, no, we don't want to do it. Or, as I've seen happen before, they might say, well, we've got these other products we want to do, and we can't invest in this product now, so we'll delay this product a year. And they'll delay starting that product in favor of other products. Maybe they want to work on an architectural product as opposed to the moving light. Or maybe they want to work on a console as opposed to the moving light. There's so many different things being built that's why this committee has to decide once they have all these facts and figures in place. Hopefully you get a go. And once you get that go, now we actually start to build and develop the moving light. So there's a lot that goes into place before the moving light is even started into the engineering department. And that's where we're headed to next. At this point, the project typically is the project's handed over to a project manager. Project manager works within the engineering team themselves and, as the name suggests, manages the project. They will put together a timeline. They will understand all the different engineering elements and know that, well, we've got to design the optics before we can mechanically design the light and know how long of space we need for the lenses. And they'll put timelines and different stage gates of points of where that will all go. And they will come up with a plan based on the full specifications. And the core team that they work with, that's these different groups of engineers. And in the next slide, we're going to talk specific about these different engineering groups. But the core teams that they work with are the optical engineers. They're the ones who design the light engine and the optics. They'll work with the electrical engineers. They're the one who design all the electronics. The mechanical engineers, who are actually working on, as the name suggests, the mechanics, and the software engineers. And again, the project manager will task them with different tasks they need at specific times to get through the project, and we'll check in with them and make sure they're hitting them. There'll be different meetings throughout the process to make sure everybody's on track. Maybe if the optics are taking longer, the mechanical engineers can't design the zoom rail just yet because we don't have the optics. Things have to wait, be juggled around. It's very, very complex, and that's why you need some person organizing the process all the way through. Now, in addition to these 4 key groups that the project manager is working with, there's many others. So they also have to work with the procurement team. and that is getting the parts in. If once the optical engineers design the lenses, you need to get new lenses brought in for testing and figuring those out. Or once the mechanical engineers design something, or someone's designed a new circuit board, that has to be produced either in your own factory or ordered from an outside vendor. You've got to procure those and get those in. You've got to talk to manufacturing engineers to make sure the light can actually be built. If the engineers themselves, the core engineers, are developing this product, but it's going to be very difficult on the manufacturing line for them to build the light, it's got 2,000 screws in it, maybe that needs to be looked at. So they have to be coordinated in there as well. There's technical writers, people who write the user manual, the warning labels, all those type things. They need to be brought into the project, and they need to go over and figure out all those different elements, as well as test engineers. Test engineers are very important people because all through the development process, they will actually go in and test different elements, because you don't want just someone writing the software and releasing it and then the moving light doesn't work correctly. You need someone to actually test that from an independent position and focused on testing those things. So all of those people are brought into the project, and they help work with the project manager and the engineering team to make the final product. Now, of course, there's the product manager is still out there overseeing this, coming in and out of the meetings and things, and checking in on progress, maybe signing off. Once they get to a point they can demonstrate the color mixing or the zoom speed, the product manager will come in and say, yes, this meets the specifications, or no, sorry, it's still too loud, or the color mixing doesn't look right, and they won't sign off and they have to keep working on it. So the product manager is very involved all through the engineering process, although the project manager is the one actually driving all that. But there are, of course, other stakeholders as well. You've got the engineering managers. This is the management team for the engineers. And they might say, well, you know, you're really busy designing the optics for this new light, but we need you to go fix something on a previous light that we're having trouble with in the field. And they might redirect people, and that can cause problems sometimes. Or they might add more people in. It just depends. And they might have their own inputs. You have the finance team. You might be ordering lots more parts than you need, and they might say, you know, you're spending too much money, you're going over budget, we need to slow down, or they might release more money. You have the sales managers as well. They're going to be saying one thing and one thing always, all the time. Hurry up, we need that light. That's what sales managers do. They want to sell it now, but they have to wait till it's fully developed and tested, of course. But they also have input. They might tell you, hey, this competitor just came out with something, we need to tweak the plan, or whatever that is. And then, of course, you have the overall writing managers of the corporation or the company, and they can make changes at any point. They could decide that they're going to do a reorganization, and they might move things around, or they might close this factory and open that one. Well, there's many different things that could happen along the way, but all these things have input into the development of that light. So there's a whole core group of people within the company that are involved in the development of the moving light. But we're going to focus in next on the actual engineering that happens with those core engineers. So, as I said, once you start actually engineering it, there's the 4 groups, and this is where the light is actually developed and where all the engineering is taking place. And when they're done, hopefully they've spit out a beautiful new product for you. But the 4 core ones are, you've got the optical engineers. And what they do, we'll start with them, they actually design the light engine and the optics. So they might work on, nowadays, working with LED arrays, but in the past they would have worked with a lamp and a reflector. And they will design and figure out how is that going to optically go through the path, work with your color mixing and your gobos and everything else to get the light coming out the front of the unit. So they'll use many different things. A lot of them will use a program called ZMAX, and that's kind of like a visualizer like we use when we program moving lights, but it's a visualizer for visualizing the beams of light as they pass through different optical elements. And ZMAX gives them ideas, so as they work with different pieces of virtual glass in the computer, they can design the size and shape of the glass, they can put how far apart things are, and it'll show how the light rays will converge from your light source and actually demonstrate output and tell them how much output they'll get in terms of lumens. It'll tell them how well things will focus on gobos and whatnot, give you an idea of the beam distribution. All that they can virtually do before they actually have any glass made. Once they do have glass made, typically glass is made initially poured and custom lenses are made one-off because you're just testing. And those are very expensive to have lenses tooled up and made, but it's part of the process. And those are made and put onto a rail, as you see in the image there. And that rail allows the engineers to then work with it to fine tune in reality how it's really going to work. So it'll be some sort of light source that they'll hook up and have their lenses, and then they'll project on the wall or in different sources to really see if what they visualized comes to fruition in reality. And they'll tweak it from there. And then that information gets passed on to the next engineer, of course, the mechanical engineer. The mechanical engineer is the group of people that's putting everything together mechanically, as the name suggests. And they'll use a lot of CAD programs. They'll design the product itself, the aesthetics, what it looks like on the outside, as well as how it all goes together on the inside. Everything from down to the actual gears, the wire harnesses, how they run, which pieces of metal go where. They might actually select pieces of metal and drill holes in it to reduce weight. They've got to figure out every bit of how that actual object comes together. Really a daunting task, but great people that put all that together. Those mechanical engineers are something else. Next up, you have electrical engineers, and they work on the actual circuit boards. So part of the design, everyone knows we need to have motors that move the lenses and the pan and tilt, and we need logic boards that do the logic to control things, and sensors, all these different things. So you have electrical engineers that design the circuit boards, and then they design those in different programs such as Autodesk Eagle or a couple of different programs that do that. And they will make the circuit boards or the PCBs, and they will have them made either in their own factory, or they'll send them out to a PCB house that will make them, and they'll be sent in. Then they have to test each of those different electronic components, make sure they're all working before they're put into a mechanical light to actually move and turn the engine. They have to actually test that and make sure everything came out as they designed it. And then, of course, you have software engineers. And software engineers are writing code. They write code in many different languages. It depends on the company and what their application is. They'll write the code, and they will also specify specific things. They might say they need a sensor here for a gobo wheel. So maybe you've got a gobo wheel and they need a sensor so they can detect where it's going to be in movement and make sure when you call it gobo 5, that gobo 5 is selected. And they'll specify what those sensors are and what data they need back. And then they can write the code to make that all operate correctly. And they have to also understand and set limits that go back to working with the mechanical engineers and the optical engineers as well, because there might be limits. If the software engineer just drives a pan and tilt too fast, it could actually break things. So they need to know what the limits are. Sometimes what happens a lot in development, you have the lenses moving in a zoom system, and if you don't set limits, what happens is the lenses can crash together, and they can actually crack or break in testing. So they have to understand how things interrelate with each other, and they have to write all that code, as well as all the other code to respond to DMX and everything else. So this core team of 4 engineering groups really comes together to build the product. And they will work together through those timelines set up by the project manager, and they'll put it all together and hopefully spit out a beautiful new light. But of course, they don't just do this in a vacuum and create a light. What happens is they make various prototypes along the way. Sometimes it's just little key elements on their desk. I remember one time as a product manager, I was invited to come see the development of a new zoom lens system, and the optical engineer had designed it, and the mechanical and the software had come together, and they just had on their desk a little sample of this, and they could press buttons and it would run back and forth, and I could see that. That was a form of a prototype. It was just a prototype of one element of the light. Other times, they'll make prototypes that are actually look just like the real light. It might look very similar to the final product, or it might look really silly and be kind of hobbled together in a way. And sometimes these prototypes will sit on the various engineers' desks with wires sticking out and all. But eventually, you'll make that first run. You'll make the alpha run of prototypes. And typically, these are built by the engineering team themselves. They'll make these in their own labs, and they'll kind of build it up, and it could be, again, like the one I showed you with cardboard on it, or it might kind of have rough edges to it. Just kind of they've assembled themselves, and they tweaked it and turned it, and there'll be zip ties all over it and tape and crazy stuff. It doesn't really look like a finished product yet, but it's really just for their use, for their own testing and proof of concept almost, because a lot of times once you start putting it all together and you put the light engine in there and you try to check the airflow and you want to make sure the light's coming out through the lenses and where the color mixing is, you might find that all your great planning worked, but if you just move those color flags forward by 0.5 millimeter, it's going to color mix much better. And so that's what they'll determine at this stage with these alpha prototypes. They'll also bring in the test engineers at this point. And the test engineers will go through and start testing the code and start operating things. And they might find, oh, you know what, the tolerance here, there's not enough space. The gobos keep getting caught up on the next module next to it. We need to add some space. So they'll start testing and really figuring out and reporting back to the engineering team things that need to be improved upon. Next step is typically a beta version of the fixture. So now you've got beta version prototypes, and these are a little bit further along. You've started to solidify the parts coming in from your vendors. Again, typically they're built by the engineering staff, but this run starts to actually look like real products. Sometimes we'll bring in the support staff at that point and let them kind of give their input and give some information and say, you know, this is going to be really tough in the field for someone to take apart when they're hanging from a truss. So maybe we need to change this or that. We'll also bring in the technical writers with beta versions, and they might get one for their desk so they can start taking it apart, understanding the modules, understanding what parts need to be written up for the users to understand in a manual. The other thing that happens at the beta prototype period is we start to see sneak peeks. And this will happen. We'll have the manufacturing team maybe come take a look at the product, start to understand what it is, how they can build it into the manufacturing line. As I've mentioned before, they might have input and tell you, well, you've got the wire harness running on the right side here, and it's right up against this piece, so that's going to be very difficult for our team to build. If you move the wire harness to the other side, it'll be easier, there's more space. So they'll give you some input at that point to maybe change up the design slightly. This is also a point when the sales staff might start to see the beta units and get excited. And they might want to show them to select customers. And that's really a fun time because you might bring customers into your factory or your manufacturing area, or you might sneak out some beta units and show them in a private space. We just launched recently at Martin the Aura PXL that we launched earlier this year, I think around March or April. But we showed beta versions of that to customers 6 months before, and we got input, and they gave us ideas, things we could change and improve that light before it came out. So it's really an important stage with that because you still have time to make changes to the product. So you get a lot of input from the beta prototypes. Then finally, you manufacture what are called the first article prototypes. And these go down to the manufacturing line or into the factory itself. And they're built the first time that they've ever manufactured these actual lights in the factory. And they're going to find problems along the way. They're going to say, again, you know, maybe the cable harness is wrong, or they've got to develop a different jig to put together to lay out to assemble the color mixing flags. They'll figure all that out while building the first articles. And they'll take longer to manufacture that first time, but they'll get better and they'll have a better understanding of what it takes to build those lights. This is also the time that the test engineers really, really dive into these lights and try to figure out how well are they working. What do they do? We're there. How can we break them? That's what they want to find out to make sure that the light is perfect when it gets released so that the end users are not getting a light that hasn't been tested. That turns out, well, when you bring the red flag in, that it gets caught up. Well, we want to check that out ahead of time. Again, the sales staff comes in. You might even bring in customers at that point, or sometimes even with first article units, those might be snuck onto a show. So maybe 6, 8, 4 of them, 12 of them, whatever, might be put onto a show free of charge. And the engineering team, some of them will go out there, or support staff, and watch and take note of how those products worked on that show in specific, what went wrong, what needs to be changed, small little tweaks that can be improved, because you don't want to just build a moving light in the vacuum of your company. You need input for the ideas, but also input for the final product before you start selling it. And that's really a key thing with those first article prototypes. Get those out there into the hands of a few customers kind of quietly and get their feedback and make those changes. So that, is how a moving light is developed. I know it was very general, but there's more to it. There's still more coming, but the engineering takes quite a lot, and it's not that straightforward, because what happens is there's always tough decisions along the way. different things that come up that you could not account for. So while it's pretty straightforward, make a light, get these 4 engineering groups and make it, there's all these different things that can go wrong. The first one is probably the biggest, is there's compromises. There's always compromises along the way. You might have those specifications and say, well, it needs to be 60,000 lumens of output, and it needs to weigh 50 pounds, and it needs to cost $6,000. But along the way, you come to find out, well, it's going to cost us a little more, or it's going to weigh a little more, or, hey, guess what? We can actually get 80,000 lumens out of it. That's cool. We can do better. There's always different compromises along the way. The decisions have to be made. Are we going to make that change or not? I've seen products where you look at it, the color mixing, and say, well, that's really not as good as it should be. And so now they have to go back to the drawing board and work on the color mixing again and redesign the flags to make it even better. Or the company just decides, you know what? Nope, we need to get our return on investment. You need to release that product. It'll be good enough, the color mixing, go. And unfortunately, that does happen sometimes too, and things just get released. It happens more often with consoles, funny enough, because consoles take a long time to develop, they cost a lot of money, and there are points when they just have to be released right away by the management team. The other thing that can happen compromise-wise is feature creep. And this is where different stakeholders, it could be the engineers, it could be the sales team, different people might say, you know what, this is looking really good, but what if we put LEDs on the outside to make the whole light glow? That'd be cool. And now there's feature creep, and that gets added in, and that's going to cost more money, and it might be another feature, it might be more mechanics, it might take more time. All these things weigh in during the development. I saw a light once I was working on, and we were pretty far down the development path, and one of the major stakeholders, one of the management team said, we need to put an iris on this light. And we went back and forth on how much more it was going to cost for that iris, and whether that was going to be a good return on the investment. How many more would we sell because we had the iris? Ultimately, we put the iris in there. It cost more money, and I don't think it was necessary, but it was there, and a few customers might have used it. At any rate, those things happen. Unfortunately, what does also happen to the product manager and the development team is sometimes there are also features that get written out and never get developed. And there's been many great features in this industry that never saw the light of day. Sorry for the pun there with the light. But there are many great features that could have been developed that just have never made it out to a product. And that's kind of sad when you know what those are. Another compromise along the way is the naming. The name of a product is always very tough. And you've seen things like we have the Mac Viper, the Aura. There's other products out there from other manufacturers. Some of them have names that are very hard to pronounce or understand. And this can come from different reasons. There might be a different reason for a name. Sometimes there's corporate rules. I once worked for a company that said, well, you have to name products with numbers and letters. You can't have an actual name. Oh, but there's an exception if you do this. And so there's many different things that can go into the product name. But Richard Bellevue of High End Systems once told me when we were working together, it doesn't matter what you call the light. If it's a good light, people will want it and they will learn to like the name. And I always thought that was an interesting take, because I do agree that if you make a good product, it really doesn't matter what it's called. People will latch onto that name and call it by that, or they'll make up their own subname for it. Gobo selection is always a compromise and a tough decision. We as manufacturers, we want to please everybody. Whether you're a theater designer, a concert designer, you're doing EDM and you want lots of aerial looks, whatever it is, we want you to be really happy with our product. But we can only put so many gobos in, 6, 8, 12, 20 gobos in a moving light. We can't please everyone. It's a very tough decision to decide what are the gobos we're going to put in this next moving light. Are we going to do the same ones as a previous light that people liked? Are we going to go a different direction? And you know, no matter what, when you start showing this to customers, to designers, to programmers, people will tell you, oh, I don't like that gobo. I don't like that gobo. You need more trees. You need more of the, whatever it is. You can't please everybody. You ultimately have to decide on a good set of gobos that kind of matches all the way around, keeps the majority of people happy. And remember, they can change them out if they want. But gobo selection is always a tough decision point with the development of a new moving light. Plus, there's always delays. There's always delays along the way. You might have problems with your vendors. They might not be able to deliver that on time. tooling might take longer than you expected, or you might not be able to afford new tooling, so you have to only go with one set of prototype lenses before you go into actually making your full ones. There could be problems, as I've described. You got to go back to the drawing board and redesign the color mixing flags, or you've got to refigure out this, or maybe the engine keeps overheating, the light engine, so you've got to figure out how to better channel air into it to cool it. All kinds of delays in that, and you've got to decide, okay, how much time are we going to put into solving this problem, or are we just going to release the light and let it be okay? Many different decisions have to be made based on that. And then finally, the other tough decisions come around compliance. Most products have to go through some sort of compliance, so you've got to designate hopefully a first article or a beta unit to send off to an independent lab for testing. So there's testing for UL listing, EU, FCC, CSA, which is Canadian, many different types of compliance that often needs to happen. And you send this off, this unit, and they'll test it electrically, they'll test it, the FCC, for emissions of different radiation and things, different frequencies. They might also test for pinch points of fingers, all kinds of things that hopefully you caught, but if you didn't, they're going to send it back to you and you need to make corrections. Those corrections take new engineering time, maybe new tooling, and then once you make those corrections, you've got to send it back to the lab, get back on their time frame, and get that compliance approved again. That is all delays that can happen, and you've got to make decisions around that and decide what you're going to do and how you're going to ultimately get that compliance. So once you've done all that, now you've got your moving light, you're ready, you want to launch it. We're ready to launch it out and make it into the world so that people can utilize the product. But you can't just spit them off the production line and say, here it is. Of course, there's a lot that has to be planned with that. So you have to plan and prepare. Hopefully you pick a date when you're going to launch. Quite often that's a trade show. So a lot of times our people in our industry will launch products at LDI or Pro Light and Sound. Somewhere around those dates is pretty common. Now, it doesn't mean the product's shipping at that date, but it's announced and launched and first debuted and shown to people. Just like Apple does their iPhone announcement, and then a few months later, they're actually shipping, because it takes time to build the products, of course. The other thing you do early on is you want to send, as a manufacturer, you want to send data to others, as I put here. What I mean is you need to get the the DMX layout, the protocol, out to consoles and to visualizers so they can have that data in there so that people can start pre-planning to use your new product on a production. The new GDTF, that data, you might want to build that and distribute that out through that system. Maybe you need to build the CAD symbols so that lighting designers can start to specify these for their show next year when they get excited that this light's coming out. So you need to get that information out there to other people, as well as start planning within your own company. And then you actually have to build them, right? So the manufacturing team has to take on those lights. They have to learn how to assemble them. They have to figure out the best process and how long it's going to take. They need a QC department that has to figure out how they're going to judge the quality of the light. Some of that comes from previous products that they know how to measure and test, and how long it takes to test color mixing flags or whatever that is. So you've got to come up with a quality testing plan. You've got to have a plan for sourcing the parts so that you know how many parts need to be coming in the door so that you're building those on time. And somebody has to design and develop and order the packaging. Moving lights aren't just thrown into a box or a road case. That has to be designed. Somebody has to design the best way to package it up so it can transport on trucks or on road cases. And the design and layout of that box and the packaging has to be developed and designed as well. Of course, you need the marketing team to let everybody know that you've got this new light and that it's out there and ready. And they need to have fixtures to take pictures of. So you need those first article elements for them to take photos of the product. Maybe you need to make a marketing video. Maybe the product manager will introduce that in a video. Maybe you need tons of them in a video to really show off what it's doing. They have to make the web page. They have to do advertising. They have to plan trade shows and how they're going to demo it and show it in the trade show. And of course, they also need to schedule times for people like Mike Wood and others to do product reviews so people are aware of this product and how great it is, hopefully. The sales team, they get involved in the launch as well. They need to forecast. Okay, we promised that we would sell 5,000 of these a year. Let's break it down now. How many are we going to sell a month per region? In the United States, we're going to sell 100 a month, and in the UK they're going to sell 100 a month, and in Asia they're going to sell 100 a month. So now we know we're going to sell 300 a month. Is that going in line? They'll actually forecast that, and they base that on current market conditions. They need to look at the market. What does the competition have? When this light finally comes out, is it still a viable thing, or do we still think we're going to sell 5,000 of them? They'll talk to the production companies. These are the rental companies and production companies typically that are buying the moving lights. And they'll find out and say, okay, we're ready to sell this. How many are you going to buy? Can we pre-sell you a bunch? Can you have these because we know this tour is coming and hopefully they'll want it? And they really work a lot to get the lights into the marketplace. And they do this through demos, of course, going to the different lighting companies, demoing the light to them, and hopefully getting them to place orders. And sometimes there's some seeding. Sometimes it happens, it's not wrong, it does happen from time to time in our industry, where somebody might go and place a large number of lights with a particular vendor or rental company and say, you know what, you use these for a while, and then report back to us, but we won't charge you for them, you can buy them after a certain amount of time. Or sometimes it's kind of cheating in a way, they'll give them to them to use for no cost, and they'll make the market think that this light is very popular and being used, even though it was not actually paid for. There's different things that happen. Some are good, some are bad, but it's important you've got to start selling the product. And you need specifications, because you need lighting designers to say, hey, I want this light. There's a big problem in our industry, actually, the chicken or egg problem, is that do lighting designers, they want to specify a light and say, oh, I want 200 of these new lights on my next tour. Well, the rental company, they don't want to buy them until they know that there's specifications for them. But now lighting designers don't always want to specify them because nobody owns them yet. So who goes first? It's always a tough game. So lighting companies have to go out and get lighting designers to hopefully be educated about this new light. What is it? What's it do? Why would I want to use it? Get them educated about it through the use of demos and all. And then those lighting designers will be specifying these lights and say, on this next Broadway show or this next TV show, I hope to use 50 of these lights. And then that will require a production company to want to purchase them. And hopefully that works all the way up the chain. There's also in that place, there's also seeding or loaning of units that could happen as well. Maybe a manufacturer will say, you know what, for your upcoming TV show, for this award show, we'll loan you 20 of our new light to put on the award show and kind of test it out. And that gets the designer using it. It gets a rental company getting it in their inventory to use for a brief period of time. And it gets some press out there about that product being used. So it's really a kind of exciting time once you get to this moment, because you finally get to the first show. Finally, the lights are out there. You hopefully have made them and sold them, told people about them, got them specified, and they're out there on a show. Yay, now you get to see your light doing what you always hoped for from the very beginning. Now what happens then? Well, you want to do some field reports. Hopefully the first few shows, you have some staff there from the manufacturer who can actually see what they're doing, or you're in contact with the lighting crew, find out, make sure it's working fine. What if on tour, the first tour ever, the tilt locks are breaking on the units? You need to know that. You need to redesign that. Hopefully the manufacturing company has what's called sustaining engineering. That's a team of other engineers that aren't building new lights, but instead they're changing the manufacturing and keeping the light running. So when they find out that, oh, the tilt locks are breaking, they will go in and they will redesign the tilt lock. And the other engineers will still be working on the next product. Sometimes it's not a separate division. Sometimes it's all the same engineers, and that will slow down something in development while the engineer has to take the time to go fix something that was just released. And then hopefully you do case studies of those first shows, get the press out there, get reports, get videos done for your marketing team. And that's how we get from idea to output. And again, ideation is always happening. The product manager is always out there looking for new ideas for new moving lights and trying to find those. And it can take many years from when that idea first comes to fruition, is kind of somewhat planned, until it's actually developed and released. It could take 3, 4, 6, 8, 10 years for that moving light to be something. The actual engineering project generally takes about 2 years. It takes about 2 years when they start building it until it's released. But the full process can take, I'd say, probably typically about 4 years for a moving light. Other products can take more time as well. So hopefully you have gained some great insight into how moving lights are developed. Hopefully I've opened your eyes up to that. And I'm ready to take any questions you might have. And on the screen are some contact information for me as well if you want to reach out to me separately.
Hey, Brad, we had one question come in and we had a couple from before the session started. So the first question is, where does the name Mac come from?
That's the Martin automate. I'm trying to remember exactly. That was before my time at Martin. There is an acronym for it, and I'm sure some of my colleagues are shouting it at their computer right now. And I don't want to misspeak, but it is an acronym that I don't recall. Sorry.
Okay.
In this moment.
The next question is, how does the development process of a console or media server differ from a moving light?
Oh, yes. So as I just described, a moving light follows these things. When you get into a more software-based product like a console or a media server, it's a little different because you're not building so much stuff. Of course, a console, you build the layout and all, but it's not very involved mechanically. So really the difference is your timeline and your roadmap becomes software features. And so you have to map out these different software features and different versions. Where a moving light, you build it once typically, and you might have some maintenance software, but you don't really change it a whole lot. But a console project, you have the initial development of the hardware, and then from there it continues to develop as different software releases. It have to be planned and processed very much as I just explained, going through the same dynamics. You'll come up with a software release plan that the next release, version 2.0, will have these features, and then you'll write the specs for those features. They'll get assigned and developed and made in much the same process.
Great. So a question that just came in, how often do you get a few years into the process and then find out a competitor is putting out a similar light prior to your scheduled release date?
Yeah, unfortunately that can happen, and that if your product is still better, then of course that's good, but it might mean that the rental companies and designers already picked that other product as the one. So you've got to watch for those market conditions. Depending where you are in the process, you can then deviate and change. So maybe you deviate and add in another feature, or maybe you get a different light engine to make it brighter. Or you might decide, you know what, there's this other company, let's park that for a while. We'll come back to it another time when we can make it brighter and better. Or you might decide again to add on to it. Or you might just continue your course and know that your product is better and watch how their product is come out first and watch for its problems and try to capitalize on their problems of the benefits of your product.
Great. This next one has a couple parts. So the first part is, can you point to any products, Martin or otherwise, that either wildly outperformed initial expectations or underperformed? And then the second part is, and speculate as to why.
Yeah, I could tell you one Martin product that was really cool many years ago is the Mac 101. And that product they actually developed in a very fast methodology. They didn't necessarily plan that it was going to be this big hit, but they developed it very quickly in a different process and spit it out, if you will, and it took off. And it was a really, really popular product, and it was very much used on lots and lots of shows and very exciting for Martin and for a lot of customers. So that one took off in a way that was not expected at all. Something that kind of didn't hit as well as they thought. There was a product I was involved with at High End many years ago called Showpix. And this was one of the first ever moving head LEDs with lots of LED rings and all. And we did a lot of work on building a media server into that engine. And it was really cool. And I really liked what we developed, the way it operated with this media server built in. But unfortunately, it was very complex and the LEDs were too wide. And it was hard for people to understand because it was early in the LED moving head range. And it just didn't take off the way it could have and the way we had high hopes of it taking off.
Great. The next question is, when a fixture spec includes a new design for an existing element, like the new color gradients on the Encore color wheel, who needs to be sold on spending the time and money to develop them rather than using the existing design?
Who needs to be sold? Well, if you've presented a good case of why you need to improve upon it, I think it kind of speaks for itself. But otherwise, you do need to sell all the main stakeholders. Sometimes you have to tell the engineers, look, what we had before in the Viper was great, but we're going one step above. We're going to make this better. And you have to convince just the engineers, the optical and mechanical engineers, this has to be better. Well, why? Why not? Let's make it better, right? Um, so I think I answered the question. Why you would want to make it better is because you want to. And who do you have to convince? We have to convince everybody, always.
Great. There is a second part to that question. It says, how often do things like that get voted down?
Usually those get voted down due to time and money. So it depends on the nature of the product. In the case of the Encore, it was essential that that product was top notch on every level and everything. That was a core tenet through the development of the Encore, was that it was the top range, better than anything that we'd ever developed. And we wanted to make sure that we re-looked at everything, because what happens in development is a lot of times you will, to help speed development, you'll say, well, we already know how we rotate a gobo, so we'll just use that same code. We'll use that same gobo design, that same gear design, and reuse it again on a new product. But sometimes it's good to start fresh, and start fresh with new ideas and how can we improve, make the gobo rotate smoother and slower than we've ever done before. And so, yes, sometimes they do get kicked out and sometimes they live on. It really just depends on what it is, and that goes back to those compromises have to be made always along the way.
So, a question that came in before the session: how does one become a product manager?
Yeah, there's unfortunately not a whole lot of product managers in our industry because there's not a whole lot of manufacturers in our industry, and each one only has a few product managers within them. Most product managers are people who've worked in the manufacturer for quite a while. Typically, it happens that most people start in a support role and kind of develop themselves up through the chain into the product manager role. But sometimes it could actually come from within engineering as well. I've seen engineers or project managers in engineering shift to become a product manager. A lot of people are technical people that started off like I did, wanting to and working on shows, and then transitioning into working for a manufacturer for many different reasons, and then just build up to eventually becoming a product manager.
Great. So, it looks like we have one more question. What is your favorite product that you are part of the development team?
Uh, I've been fortunate. There's been a lot of great products and different things I've been involved with, lots of different lighting products. Um, I would say probably one of my favorites that I had an opportunity to be involved with and be a part of the team with was the Whole Hog 4 project. That lighting console was really exciting to design a new platform and product from the ground up. I had worked a lot with the Whole Hog 3 range, and with the full bore and the other elements of that. But then when we started actually starting fresh for the Whole Hog 4, that was exciting. There were a lot of the digital light era that was fun, and even the current moving lights. There's been all kinds of different things. I mean, just like when you're designing a show, you put everything into that moment in that show, and that is the best show ever. When you're working on a moving light or a lighting console, you put everything into it, and that's the best product ever. So they've all had really great things, and I'm proud of every product I've been a part of, even though not all of them took off as a grand product in the industry. Again, the most exciting thing is to go watch a show or turn on a TV show and look at something and say, oh, I was part of helping make that light and develop it. And I remember when we changed it to do this or that or whatever it is. And that's the most satisfying thing. It's just exciting.
Great. Well, that looks like all the questions that came in. I want to thank you, Brad, for your time. The session was great. And also thank you, everyone who joined us today.
Yeah, thank you. This was fun. And again, if people have further questions, my information's on the screen. Feel free to shoot me an email, and I'm happy to answer any questions. And thank you for joining.
Perfect. Everyone have a good afternoon.